So this is lab 6. It is called That Voodoo, That You Do So Well by Shane King, Gladys Sepulveda, and Haley Wilton. So to begin, the overall purpose of this lab is really to get familiar with the coefficients of static and kinetic friction. Static refers to when the object is not moving, so it would be when it's on the ramp, and then the kinetic friction would be once the object begins to move, and particularly we're looking at friction on an incline. For this experiment, you'll need a tripod with phone mount, a meter stick, 2 different objects to slide down the ramp. You can do another ramp if you choose, an angle gauge to measure the angle, a crash pad, laptop, smartphone, and 3 group members. 1 group member will be the videoer. Another person will watch the angle gauge just to make sure that it's the right angle that it drops, and then the other person will move the ramp up. The objects we chose for our experiment specifically was the adjustable painted metal incline, and our object 1 was a dry erase board eraser, and object 2 was a small steel cube. So now for our static friction data, to make the measurements more accurate and precise, we did 10 trials and of our chosen objects, which were the block and the eraser. So the uncertainty in our critical value was 0.05, and we determined that based on the digital angle gauge, which measured at 0.05. And then for our dry erase board eraser, we got an average critical angle of 32.32 with an uncertainty in the average critical angle of 0.4. For the steel block, we got an average critical angle of 20.45 and an uncertainty in our average critical angle of 6.7. And with all of our trials, for our steel block, we noticed that we had some outliers in our data. Angle for our dry erase board eraser was 50.45, and for our steel cube, it was 39.95. In order to find these angles, you have to first put the object, start with the ramp flat. You'll place the object on the ramp along with the angle gauge, and then you'll have one member slowly raise the ramp until the object slides down, and the checker will watch the angle gauge to determine the angle. The angle at which the object does slide is the critical angle, like I said before. In our next slide, we have the experiment videos. Our video to the left shows and represents the video of the eraser at the critical angle of 50.45. And our video on the right shows the experiment of the block, which is at a critical angle of 39.95. So in order to get your kinetic friction data, which, like I said, kinetic friction refers to the object once it is moving, to find this, you want to raise your ramp about 15 degrees above the critical angle, and you'll put your object at the top of the ramp, and you want to start a video at the same time that you drop the object, and you're going to want to make sure that that video is in slow motion just so it's easier to see everything that happens. And then You'll stop the video as soon as it reaches the crash pad, and you will repeat this whole process again with your second option. With your second object, you'll do this twice. So with the eraser, we did the tracker, and in our graph, it shows our fit is a parabola, and it's going in the positive x direction. For our A value was 1.33 with an uncertainty of 0.02. Our B value was 3.7 times 10 to the negative 1, and our uncertainty in B was 0.1. Our C value was negative 2 times 10 to the negative 3 power, and our uncertainty in C was 2. With our acceleration being 2.66 meters per second squared, and the uncertainty of our acceleration was 0.04 meters per second squared. As said in the previous slide, our steel block also has a fit of a parabola, and our tracker represents a great fit of the parabola, as well as the values of A, B, and C. A, B, and C. Our A value was 2.26 with an uncertainty of 0.04. Our B value was a negative 5.0 e to the negative 2, and our uncertainty was 2. And our C value was 2.6 e to the negative 2 with an uncertainty of 0.3. With that being said, we calculated our acceleration with those values, and it being equal to 5.32 meters per second squared with an uncertainty of 0.08 meters per second squared. Conclusion is our erasers mu k is 0.78 with an uncertainty of 4.68 e to the negative 6, and the block's mu k is 0.13 with an uncertainty of 2.26 e to the negative 6. The eraser's mu s is 1.21 with an uncertainty of 0.403, and the block's mu s is 0.84 with an uncertainty of 2.6. Our uncertainties are very large due to the outliers that we've had in our previous data. Throughout this experiment, as a team, we benefited because it educated us on how to better understand the coefficients of static and kinetic frictions.